Hello, welcome to Chemistry Chapter 16 Final Exam Review, Worksheet Solutions. So you'll need your worksheet, and don't really need a calculator for this. And I put the rules for the oxidation numbers up here at the top of the worksheet, but you won't get that on the final exam, so you will have to have those rules memorized. All right, so number one, we need to get the oxidation numbers for each element in these compounds. So for A, hydrogen has a rule, it's +1. Lithium's in column 1, so it's a metal in column 1, so also +1. So what we'd have is 1 times 1 plus 1 times 2 for the hydrogen, so that's 3. So nitrogen needs to be -3 in order for the whole thing to add up to 0. All right, for B, hydrogen has the rule +1, so in this case nitrogen would need to be -1, so we'd have -1 times 2, that's -2, plus +2 adds up to 0. Okay, so for calcium, calcium's in column 2 on the periodic table, so it has a +2. And then oxygen would be -2. So we have 4 oxygens here. Times -2, that'd be -8. All right, plus 6. So we need nitrogen to be +3. Now, if you need to write all that out, go ahead and do that. But 3 times 2 nitrogens would be +6. Plus 2 plus 6 would be +8. And then -8. All right, so again, if you need to write them out with blanks like I taught you or your teacher taught you in the beginning, go ahead and do that. All right, so -2, so carbon would have to be +4. 4 minus 4 equals 0. All right, this time BF4 minus, we have to add up to -1. Fluorine has a rule, it's -1, so boron would have to be +3. 3 minus 4 equals -1. PO4, oxygen has a rule, it's -2, so phosphorus would need to be +5. 5 minus 8 would give you -3. ClNO, so we have -2 for oxygen. We're going to have to go to rule 7 for chlorine. It's in column 7, so it would be -1. So that would force nitrogen to be +3. Nitrogen's a real wild card. You can see the nitrogens in all of these compounds are pretty much different. All right, and then O2 all by itself. It's easy to make this mistake to put -2, but it's an element all by itself, not part of a compound. So it's the charge divided by the number of atoms. The charge is 0. So be careful. The most commonly missed on the test would be something like an O2 or an H2, giving it a -2 or +1 when it's 0. All right. So number 2 says an atom goes from -5 to +3. Is it oxidized or reduced? And how many electrons are a part of that? So -5 to +3. -5 to 3, that's going to be 8 electrons. The oxidation number is getting bigger. It's not reducing, it's getting bigger, so that means it is oxidized. All right, number 3, -1 to -2. So that's just going to be 1 electron. And the oxidation number is going down. The oxidation number is reducing. So this atom is reduced. Okay, 4 we have, we need to determine if it's redox or not, and then which elements are oxidized and which are reduced. So we have Cu2+. We don't need to know the phase, so I'm not going to write that in. Plus copper. Okay, so our oxidation numbers are plus 2 for this copper, charge divided by the number of atoms, 0 for zinc all by itself, plus 2 for this zinc ion, and 0 for copper. So the oxidation numbers change, so it is indeed redox. Copper goes from plus 2 to 0. The oxidation number is going down. It is reduced. And therefore zinc would be oxidized because you can't have reduction without oxidation. All right, part B, we have 2H2O. And that yields 2H2 plus O2. Okay, so for oxygen it's -2. For hydrogen would be +1. Both of those have rules. And then we have a rule for hydrogen all by itself, oxygen all by itself. So it is a redox reaction because the oxidation numbers change. Hydrogen goes from +1 to 0. That is reduced. And then oxygen would be the other one. It goes from it's getting bigger, so it's oxidized. All right, part C, we have NaCl, sodium chloride, plus silver fluoride. And that yields silver chloride plus NaF. Okay, sodium +1, it's in column 1, so chlorine would have to be -1 in order to add up to 0. Fluorine has a rule, it's -1, so silver would be +1. We're going to have to go to rule 7 here. Chlorine's in column 7, so -1, so silver would be +1, and then +1, -1. None of these oxidation numbers change. So this is not a redox reaction. It's actually a double replacement reaction because sodium is replaced by fluorine and then fluorine is replaced by chlorine. Okay, part D, we have calcium plus HNO3. That yields CaNO3 plus H2. All right, we'll go left to right. Calcium all by itself will have an oxidation number of 0. Rule 1. We have -2 plus 1 for hydrogen, so this nitrogen would need to be +5 in order to add up to 0. So we'd have calcium in a compound is +2, -2 for oxygen, so that's 6 oxygens times -2 would be -12. I need a +10, but I have 2 nitrogens, so that would be +5. And then hydrogen by itself will be 0. So calcium goes from 0 to +2. Its oxidation number is getting bigger. So calcium is oxidized, and then hydrogen would be reduced. Nitrogen and oxygen stay the same. All right, let me clear the board, and we'll do a couple of these galvanic cells, and that will be it. All right. So number 5, we want to draw and label a galvanic cell. And we have 2H plus. We do need the phases. Plus 2Al. That yields 2Al3 plus. plus 6 Cl minus. All right, we need to go, I'm going to go left to right and put the oxidation numbers, figure out what's oxidized and what's reduced. So hydrogen ion would be the charge, plus 1. Aluminum by itself is going to be 0. Then plus 3, minus 1 for chlorine. So hydrogen goes from plus 1. Oh, I accidentally mixed. This is actually not, I'm so sorry. This is not number 6. I got number 5 and number 6 mixed up there. So it's plus manganese. And then that'd be H2 gas plus Mn2 plus. All right, and so manganese would be 0, hydrogen 0, and then manganese plus 2. So hydrogen goes from plus 1 to 0. The oxidation number is reduced. So hydrogen's reduced. That means hydrogen is gaining electrons. Because electrons are negative, if the oxidation number is going more negative, then the hydrogen through this reaction had to gain electrons. Electrons are attracted to the positive side of the battery. So that would be the cathode. So manganese is oxidized. That makes it the negative side of the battery because electrons are fleeing. Like charges repel, electrons are negative, so they're fleeing. That makes it the anode. So let me draw the basics of the galvanic cell. A couple of beakers. Very rudimentary. Couple of electrodes. I do like to put the anode on the right, the cathode on the left. We have some solution. Got a salt bridge. Make sure your salt bridge goes underneath the solution so that those ions, label the ions, so it's a source of positive ions for the left side and negative ions for the right side. We need to connect the electrodes by a wire. The electrons will flow from negative to positive. We'll say this is electron flow. This is an electrode. All right, and then this is the cathode. This is the anode. So that's good for the basic labeling. That gives you half the points. The other half of the points come, did you get the anode side and the cathode side correct in terms of labeling these reactants? Well, H plus is in solution. It is the cathode, so we need to write that in the solution. So H plus solution. Then the electrode on the right side is made of solid manganese, so it's a manganese electrode. And that will do the trick. All right, let's look at number 6. I'm going to use this same drawing for number 6. We have 3Cl2 plus 2Al makes 2Al3 plus. Plus 6Cl minus. All right, in terms of oxidation numbers, for Cl2 it would be 0. For aluminum, 0 by itself. Plus 3, it's the charge, and then the charge -1. So chlorine's going from 0 to -1. That means chlorine is reduced, making it the plus side of the battery, which we call the cathode. Aluminum is oxidized, making it the negative side of the battery, our source of electron flow, and that would be the anode. So all we have to do in this diagram, and on the test, if you have to do 2 of them, which I think you only probably have 1 of these, but you would draw the whole thing again. I'm not going to draw the whole thing again, but we'd have Cl2 in solution as the cathode, and then our anode would be made of solid aluminum. So that does it, not only for the Chapter 16 final exam review, that does it for all of the videos from my chemistry course. So if you are a student at Community Christian Academy in Paducah, Kentucky, I taught there for 16 years, and I have finally finished. I started making videos in 2018, and I finally finished them. I made a lot of them during COVID, and then after I retired, I continued to make them for the next teacher in case they would be helpful. So go CCA Paducah, go Warriors! I'm also the inventor of the Woot Stick, so you might not know that. So go Warriors. If you are watching this and you're not part of CCA Paducah, I hope that they help you. I have not tried to get a lot of views on them or anything. I've just made them to help the students at Community Christian Academy in Paducah, Kentucky. And so that'll do it. Kind of a nostalgic moment for me finishing this. Now I'm going to work on finishing my AP Calculus and my physics courses. So I have a lot of videos for both of those as well. So that'll do it. Please study for your final exam. I hope you do well on it. I'm the one who wrote it, so you can blame me if you don't do well. And God bless.